in the circuit shown in the figure, the internal resistances of batteries are 0.12 ohms and 0.08 ohms. Calculate current in the load 0.5 ohms. Where is the 0.5 ohms in the given circuit? It is 0.5 ohms. So we have to determine the current in this. How much current flows through it? It is already given in the circuit, that is I3 current flows through 0.5 ohms. We have to determine the value of I3 and current supplied by each battery. This means when only one source is acting in the circuit, how much current flows through this? When only this source 1, let us assume it as source 1, this as source 2. When only source 2, S2, source 2 is acting, how much current flows through 0.5 ohms, and when only source 1 is acting, how much current flows through 0.5 ohms. So based on the question that has been asked here, we can determine the currents supplied by each battery and the load current by applying superposition theorem here. So let us apply superposition theorem and determine the current in 0.5 ohms. Now, since in the question they have mentioned internal resistance of 0.12 ohms and 0.08 ohms, therefore you can redraw the circuit, okay, representing the internal resistances with a resistor symbol. So internal resistance of source 1, S1, source 1 of 12 volts is 0.12 ohms. I have drawn a resistor, I have connected a resistor here, and I have mentioned the value here. And another source of 12 volts, so its internal resistance is 0.08. so I have drawn a resistor and I have mentioned 0.08 ohms, 0.8 ohms here. Okay, now we have to determine the current flowing through 0.5 ohms. Now let us go to step 1. Let us assume only 12 volts voltage source is acting in the circuit. Left side voltage source of 12 volts is acting in the circuit. Okay, now here because of this source, what is happening? Current of I1 dash amperes, let us assume I1 dash ampere current flows through 0.12 ohms resistor here, and at this junction the current, what will happen? Current will divide into I2 dash and I3 dash. Now what is the current in 0.5 ohms resistor because of this 12 volt source? It is I3 dash. So we have to determine I3 dash now. We have to determine I3 dash. So if I want to determine I3 dash, I must know how much current is entering at this junction, means total current I1 dash. I have to determine I1 dash first of all to determine I3 dash. Now first of all let us determine I1 dash. To determine I1 dash is the total current entering the circuit because of this source. Therefore let us first of all determine the total resistance in the circuit. So I1 dash current, when it comes at this junction, what is happening? It is dividing into two parts. That means that the 0.5 ohms and 0.08 ohms are connected in parallel. Therefore you just determine the equivalent resistance of this parallel arrangement. You will get 0.08 into 0.5 by 0.08 into 0.5. If you simplify it, you will get 0.0689. Now replace the parallel arrangement by a single resistor of 0.0689 ohms. Now from this positive terminal, current will come out of this source. It will flow through this resistor, internal resistance it is, through this resistor and flows through the 0.0689. Means these two resistors are connected in series. Why? Because same current flows through 0.12 ohms and 0.0689. Therefore you can add those two resistances, 0.12 and 0.0689. you can add them, you will get 0.189 ohms. Okay, now this is our modified circuit with total resistance of 0.189 ohms. Source voltage is 12 volts. Current here is I1 dash. So now 12 divided by 0.189. So you just solve it, you will get 63.5 amperes. So I1 dash current is 63.5 5 amperes. Now I know I1, I can determine I3 dash. I have determined I1 dash value just now. I can determine I3 dash by current division rule. So current in 0.5 ohms resistor, that is I3 dash is total current, that is 63.5. Total current which we have determined here, that is 63.5 into opposite resistance of 0.5 is 0.08. 0.08 by 0.08 plus 0.5, you will get 8.76 amperes is the current flowing through 0.5 ohms resistor. Okay, current through 0.5 ohms resistor, when the only left side voltage source of 12 volts is acting, it is 8.76 amperes. Now let us go to step 2. In step 2, I am assuming middle branch voltage source of 12 volts is acting alone. Therefore, what is happening? This side branch voltage source is short circuited. Okay, it is short circuited. So since this voltage source is short circuited, its internal resistance is 0.12 ohms. And now this is our voltage source in the given circuit. So from this positive terminal, current will come out. Let us assume I2 double dash is the current coming out of this source. So at this junction, what is happening? Current is dividing into two parts. So current is dividing into two parts. That means that 0.5 ohms and 0.12 ohms, they are connected in parallel. Now our aim is to determine current flowing in 0.5 ohms, that is I3 double dash. If I want to determine I3 double dash, I must know I2 double dash value. So let us determine I2 double dash. In order to determine I2 double dash, let us simplify this circuit. Let us simplify this circuit. Since 0.5 and 0.12, this 0.12 and 0.5 are connected in parallel, let us simplify it and let us determine the value. 0.12 and 0.5 are in parallel. So 0.12 into 0.5 by 0.12 into 0.5, just simplify it. I am sorry, 0.12 into 0.5 divided by 0.12 plus 0.5, you just solve it, you will get 0.096. So this is our given circuit. Now modified circuit based on whatever simplification that we have done. Now if you observe here, in 0.08 ohms and 0.096 ohm, same current will flow. Current is not dividing, there is no junction here. Therefore you can simply add these two resistances. So that is 0.08 plus 0.096. So our equivalent resistance is 0.177 ohms. So this is it, R equivalent. So now this is our source of 12 volts. Okay, this is the total resistance, R equivalent resistance. Okay, now I2 double dash. I2 double dash is V by R equivalent. V is 12 and R equivalent is 0.177. You will get 67.79 amperes. I2 double dash is 67.79 amperes. So what is I3 double dash now? Total current, that is 67.8, that is 67.79. 67.79 I have written as 67.8 into opposite resistance, that is 0.12 by 0.12 plus 0.5. Okay, I will just copy the circuit there so that it will be easy for you to understand. So from this circuit, in this circuit you can see I2 double dash we have determined, that is 67.8. Now our aim is to determine I3 double dash current. I3 double dash current is flowing through 0.5 ohms. So what is the opposite resistance? 0.12. So 0.12 by 0.12 plus 0.5. You just simplify this, you will get 13.12 amperes. Now according to superposition theorem, I3 should be equal to I3 dash plus I3 double dash. So I3 dash is 8.76 and I3 double dash is 13.12. So you just add it, you will get 27.88 amperes. So current due to both sources, current in the load. Current in the load is 21.88 amperes and current due to one of the sources is 8.76 amperes and current due to another source is, this is 8.76 and another source is, that is 13.12 amperes. So in the question they have asked us to determine the load current, that is 21.88, and another current, that current due to each source. For due to one source it is 8.76, due to another source it is 13.12 amperes.